In this video, I'll show you how to solve for the atomic mass of an unknown isotope. So the question says that copper has two naturally occurring isotopes. Copper-63 has a mass of 62.939 U and a relative abundance of 69.17%. Use atomic weight of copper to determine the mass of the other copper isotope. Let's see what all we know from this question. We know that copper has two naturally occurring isotopes. We have the mass and the relative abundance of one of them, and we are asked to find the mass of the other copper isotope using the atomic weight of copper. So let's see which algebraic equation we can use for this. Usually there are two forms. You can either use directly the percentage abundance, but then you'll have to divide the entire numerator with 100. Or you can use ratio abundance, and this just makes the math slightly easier. So for this example, I'll be using this form of the equation, just because, we need to solve for the mass of this second isotope, and that's going to make it relatively easier than to have a denominator. Anyhow, we know that there are two isotopes of copper, right? So we are just going to use two of these brackets, but you know that you can keep on going on with this if you have 3 or 4 or more. So let's look at the data that we are given. We are given the percentage abundance and the atomic mass of copper-63, right? The percentage abundance is 69.17% and the mass is 62.939, and we have to find the mass of the second isotope, right? So I'm just going to abbreviate it to ISO 2. Now, how do we find the percentage abundance? Well, that's quite obvious. Percentage is, out of 100, and we are given the first one. So the percentage abundance of the second isotope will simply be this, and that will give us 30.83%, right? And we can plug this in here. So we have 30.83% as the relative abundance of the second isotope. The question also tells us to use the atomic weight of copper to determine the mass of the other copper isotope. Now we can find that by obviously referring to the periodic table. If you have memorized it, you can use that too. So the atomic weight of copper from the periodic table is 63.55 U. Now all we have to do is plug in all this into our equation, and I'm just going to give more space here. So we have atomic weight equals to the ratio abundance times the mass of the first isotope plus the ratio abundance times the mass of the second isotope. We know the atomic weight is 63.55. The ratio abundance of the first is 0.6917. The mass is 62.939. Now the ratio abundance of the second isotope is 0.3083, and we have to find the mass of the second isotope. Solving for the equation, when we solve this bracket, we get 43.53 plus 0.3083 m ISO 2. Okay. So when we bring this to the other side, we will subtract 63.55 with it. We will get 20.02, and that equals to 0.3083 times the mass of the second isotope. Dividing this by this, should I write it down? Let me just write it down. We get 0.3083 and this gives us 64.937 U. And this is the mass of our second carbon isotope. I hope you found this video helpful. If you did, please give it a thumbs up and subscribe to my channel. Feel free to ask any questions in the comment section.